Hey there, I'd like to talk to you today about the basics of Git and what is Git. Git is an awesome system that you can use to track changes to all your code as you write programs and work on things. And in fact, you can use Git for tracking changes to a wide variety of documents, not just code only. There's a special tool that I used a while back where I could track changes to just regular Office documents. But if you're writing text files of some sort, or even like, I don't know, making SVG graphics files or something like that, you can track changes to all sorts of stuff. Okay, so it's mostly for coding, but so what is Git and why would you want to use Git? Okay, so we talked about Git being a code versioning system. It will track your changes. Imagine this. Imagine you're writing code and you spend all day, maybe like all month, writing a really, really good algorithm or a really good function or something like that. And then maybe a year later, you haven't been using it, and you kind of think to yourself, whatever happened to that giant function that I wrote? That was really good. And then you realize, oh no, I think I deleted it like several months ago because I thought I didn't need it anymore. And now I've changed my mind. I wish I had that back. But then by then it's too late because the code is gone and maybe you don't have a backup, or maybe your backup is just, only a few snapshots deep or whatever. And so you're kind of screwed, right? So one way that Git can help you is Git lets you look back in time to the state of your code at any other previous point. As long as you've been committing your changes, like every time you make significant progress with your code, you log it in Git's database. You can just look back in time. You can look back to see what your code was 3 years ago. It's awesome. You can also, revert changes. You can sort of like branch your code off in two different directions. Maybe here you're just going to be working on bugs, and on another branch you're adding one feature that you think might be a good idea. And later on, if that feature ends up being a really good idea, you could merge that branch into the main branch. Or if you think that feature is going to be trash and it sucks and you wish you never did it, you can just delete that branch and it doesn't affect your main code branch. It's really cool. It's also a good tool for collaboration because multiple people can push to the Git database and they can get each other's changes. It's kind of a way also to cloudify your code. Like if I'm writing a program, I can commit some changes and I can push some changes to the cloud, and then my colleague can pull my changes and they get everything that I just worked on, and then they can commit some more changes and push it back up to the cloud. Then I can pull it. And so we're sort of like collaborating, and in a way where every single change is logged. Your boss can look at, or you can look at all the logs in your Git commit database and see who changed what. You can see what lines were changed, when they were changes. You can see who introduced a bug. There's a function in Git that is called git blame, where you can look at a source code file and you can see who is responsible for every single line. You can bookmark states of your code. You can do so much. It's wonderful. But anyway, I just want to touch on the basics today. I hope I've kind of convinced you that Git is a little bit of a good idea. I used to just sort of code and then do copy paste as my backup copy, and it was okay. But when I started using Git, even by myself without collaborating, it was tremendously valuable. There were many times when I wanted to look back at a previous state of code, and Git let me do it. Many times when I wanted to revert some mistake that I made, and Git let me do it. Okay, so you see my terminal here. Maybe I should reduce the transparency just a little bit, just to make this a little bit easier to see. So I'm going to do maybe like 85 opacity. That's a little bit better. Okay, so I'm going to go into a documents folder. I'm going to go into a temporary folder, and I'm going to remove everything that is, whoops. Oh, okay. That was just something I was working on earlier. Okay. So I'm in a folder. So what is a Git repository? Actually, a Git repository is just a folder with some extra information inside of it. Let me see. I don't remember if I installed Git on this machine. I did. Okay. If you don't have Git, you can get it pretty easily with sudo apt install Git. Or if you're on Windows or some other operating system, you can just go to Git's website. It's git-scm.com or something like that. You can just find the installer and just get it in there. But So let's say I want to make a repository. We'll say make directory my repository. Okay, so I've got like an empty folder. I'm going to go inside of it. And this is just a folder. It's not a repo yet. I can convert this folder into a repository by just using the command git init. Oh gosh, here's like a message. Oh, you got to choose what branch you want. I think it's actually okay at this point. I think they'll choose one for me. When you see yellow instructions like this, you can read them and obey them, but they're not necessarily mission critical while we're just learning. So notice how when I list the directory, it's no longer empty. There's a git folder inside of there. So if I go inside of the git folder, I mean, this is really not so much for humans. You can kind of do configuration stuff in here, but this is really Git's database of everything it knows about your code. You know, when you changed stuff, what's the configuration. So if you actually remove this folder, I'm going to remove the Git folder. That's all it takes. Now this folder is just a regular folder. It's no longer a Git repository. So you probably don't want to do that once you've initialized it, but I'm going to reinitialize this again. If I had a bunch of history inside that folder, then it would have been gone already. But we're just learning. This is just an empty repository. So I have a Git repository here. First thing I want to do is try to figure out what Git thinks about the repository. So I'm going to use the command git status. Whenever you're not sure of what's going on, if you think you need to commit something or push something or pull something or whatever, it's probably a good idea to use git status. Like I use it all the time, git status, and then Git will tell you what to do. It's basically telling you that you haven't done anything at this point, so that's okay. Let's make a README file. So I'm just going to make a simple README file in Markdown. My project. You don't really need to know about Markdown to use Git, although the two kind of go hand in hand on GitHub. But I'm just going to say, well, here's my project. This is my super cool project. Okay, so pretend this is a program, a complicated program. So I'm saving it. We can verify that I actually put something into that file. So now I'm going to ask Git, what do you think about the state of this repository? So I'm going to say git status. Git is telling me now that we're on the master branch and there are no commits yet. And I have an untracked file. This means that the README file is not considered part of the Git repository. It's just sitting in the directory tree. So I want to add that into my repository so I can start tracking changes. So I'm going to say git add and then the name of the file. What have I done? Okay, here we go. That's not how you spell add. So now that I've done git add, I can say git status one more time to see what Git thinks about the state of my repository. Okay. Git says, well, you definitely use the add in order to put the changes on a stage. Git likes to bunch up changes on a stage before you actually commit things to the database. The reason for that is maybe you spend an hour doing a bunch of work in a bunch of different areas of your program, but maybe there's only a few files over here that are part of a logical change. Like this is feature A that I was fixing. But you also changed a bunch of other files that were related to something else, like feature B that I was fixing. It doesn't really make sense to take all of those changes and make them one commit because you want a nice clean commit log that shows exactly what you were working on and it makes sense. So in the case where you just worked on a bunch of different files, you can add all the feature A files to the stage first and then commit that as one change, and then go over to the feature B files and add those to the stage and then commit that as a second change. So it's kind of a way to get you out of the mess you've put yourself in if you've just been working too long without committing. You should really do a git commit every time you make significant progress. It depends on where you're working or who you're talking to. You definitely don't want to commit every line that you change. You definitely don't want to work for a month and then do one commit at the end of the month. The sweet spot is somewhere in between. Your boss will probably tell you what to do. For me personally, every time I fix something, I'll make a commit. One thing, I made significant progress in my program by adding a new feature. One little feature, I'm going to commit it. Some people like to do commits at least once a day so that if they're working on a huge new feature, then they'll do one commit a day, and then they'll sort of call those several commits part of the new feature. It's up to you, but At this point, we just have the one file that we made up on the stage. It's ready to be committed. We used git status, so git is just telling us how to commit it. It's like, oh no, it's not telling us. It's just saying we need to commit it. It's not saying how. If you want to unstage it, then here's the command. But the commit command is just git commit. Now it's going to ask me for a commit message. This is what you will see in the log. So don't just put work. Don't put change. Don't put something that doesn't describe what you did. You should describe exactly what you did. So what I'm going to do is for the commit message, I'm going to just sort of say what I did. You can imagine writing something like, I created the README file. It should always definitely describe exactly what you did. But it seems like a lot of people use, I guess, grammar and terseness to make the commit message sound like they told somebody to do something. So create the README file. Instead of I created the README file, create the README file. So I'm just going to make that my commit message, save the buffer. And then now that I've committed the changes, I have to ask, git status, what did I do? What's the state of the repository? Git is now saying that the repo is clean. Everything looks pretty good. So that means my changes are recorded in the Git database. I can now actually use a command called git log to see what changes have been recorded. Notice how there's only one change. It's just, my name here, when it was changed, and then what I did. There's a hash here. This little hexadecimal string is called a hash. I can ask Git to show me what happened in any specific commit by saying git show, and then I give it a hash. And it'll tell me exactly what files were created or changed or deleted or whatever. And there it is right there. This will get more interesting in a second. Let's make a change. I'm going to say, edit the README file. I'm going to say, this is my super cool project. This is my first change to the README. Again, imagine that you've written a big program. So I'm going to say git status to find out what's going on. Git says, oh, you made a change there. It's not saying that this file is not part of the database. It's just saying that we made changes. If I want to see the changes that it's talking about, I could say git diff. And it's telling me that I added this line. My dog is growling at me. He likes to go pee and then later lie about peeing. Oh my gosh, hang on. So I'll let him back in. He'll try to lie to me and he'll try to get free treats. Okay, so we can use the command git diff to see what our changes are. We can also say git diff and then name a file, and it'll tell us what's changed in that one file. Notice how it's saying here that we've added a second line. So great. Back to git status, it's saying we need to stage that change. So I'm just going to say git add and then the name of the file. Git status again, so that we know what's up. It's saying, all right, well, you just need to commit the changes on your stage if you'd like to. So yeah, sure, I'm going to say git commit. And I'm going to say, changed the README or something. Okay, git status again. It wants me to put my author name in there. So now if we do git log, there's 2 entries. Imagine that this happens every single time somebody makes a significant change. It's just like it goes in the log. You can figure out who changed what. Watch this. Let's do cat README so we can see the README. Notice how it's got the second line at the end. I could also go back in time and see what the state of my project was after that first commit. So I'm going to copy paste that first commit, and I'm going to say git checkout and the commit hash. It's now telling me something. Hey, by the way, now you're looking back in time. You should not change anything. You're on a detached head. If you're ever unsure of where you're actually at in Git, you should do git branch all, and it'll just sort of show you where you're at. I was on the master branch. Now I'm on a detached head. But notice if I spill the contents of the README file. Hang on, what did I do wrong? Change the README. Oh, sorry, it's in reverse order. I always forget that. I copied the wrong hash. So let me check out the first commit that I made. So I'm going to say git checkout the first commit hash. Okay, now I'm going to concatenate or I'm going to spill the contents of the README. Notice how the README looks like it did when we first made it. So we've gone back in time. Think of how useful this could be if this was a huge, big project with a bunch of files and a lot of lines per file. So once again, we'll do git, actually let's do git status. Status is reminding me that we're on a detached head. And we can also use git branch to see that we're still in the detached head. You want to get back onto the master branch or whatever branch you're working with before you continue working. So we'll say git checkout master. And then just to double check, we'll do git status. And you can see that we're on the master branch. Then we can say git branch all. And there we go. Maybe we want to bookmark this. Maybe we want to remember, oh, this is a perfect state of our code. Maybe this is version 1.0. We can do git tag version 1.0.0, and now we have a bookmark forever. How can we find the bookmarks? Well, we can say git tag just by itself, and it'll give us a list of our bookmarks. When we push this to a remote server, the server will be able to show it, like GitHub or GitLab or whatever. And then later we can do something like, git checkout, and then just check out the name of a tag. So it's kind of the same thing as checking out a commit hash, but it's like a bookmark that's a little bit easier to remember. So let's look at remotes for a second, because right now we're not pushing code anymore. We're just remembering what we changed in our code. Okay, so I'm inside my repository, and now I'm going to go up a level on this right pane, and I'm going to make a new directory. But I'd like to clone the original repository. Imagine that this repository, it's a folder to us, but it could be, for all we know, sitting on a remote server and accessed with a special URL. So you could go to like GitHub or somebody's server and you can copy their Git URL for their repository. Over here in our local file system, we could clone the original repository. Usually you would have to, copy paste like a big Git URL, SSH URL or HTTPS URL or whatever. But you can even do this locally. So I can tell Git, I would like to clone this local repository denoted by this folder name. And I would like to, call it my clone or something. So I'm going to say git clone repository my clone. It says cloning and done. Now we have two folders. And if we go inside of the my clone repository, we should have the same state of code that we just cloned. So that makes sense. Now think about collaboration. We can change our code from the clone, and as long as the clone has permission to push back up to the remote, then it actually would work. So let's edit the README file real fast. So I'm going to go nano README, and I'm going to say this change was made by the clone. Okay, so I did that. And actually, just to make things interesting, I'm going to change my Git identity only inside of this clone. You can do that in Git. When you say git config and you say something like user.name, you can put your name here, your email, whatever, for like user.email. There's this thing that you usually do where you say git config global, and that means you're changing configuration that is account wide. So like your entire account on this machine is going to be changed when you use that global flag. But if I don't use the global flag, it's just changing my configuration for only this one repository. So I'm going to make my name clone dude, and I'll make my email clone dude at laptop or whatever, at server. So now if I say git status over here, it's telling me, hey, I have like a change. I say git diff, and it tells me, oh, look, you changed that last line. So I'm going to add that change to the stage, and then I'm going to commit it, and I'm going to say I added something to the README. Okay. Git status. Notice how git status is saying something a little bit extra this time. Before, we were just in a local file system only, and now we're working inside of a clone. So this is like, you clone some code from GitHub or from your friend's server or whatever, And when you do a clone, it actually automatically links your local repository to the remote repository. By the way, in Git, everything is considered a local copy. So it's not like you're working with something different than the server has. You actually have the entire Git history and all the code and everything that Git has on the remote, except for maybe some like configurations or something. But when you pull, you're just making a copy. Sorry, when you clone, you're making a copy. Later, we can push our changes to the server, and that just makes the two repositories talk to each other, sort of, and reconcile changes and make sure that both sides have the differences, I guess. So it's telling us we need one more step. It's saying git status, and it says you're on the master branch. Your branch is ahead of origin master by 1 commit. What's origin master? You can find out all of your remote connections in Git by saying git remote v. So when you clone, it automatically makes an origin remote. It calls it origin, and then it has the URL, or in this case, just the file path of where the remote is. So it's telling you that our remote, where we're connected to, is the My Repository folder that we were at in the left pane. So it's telling us also, if we go back to just status, it's telling us that we should use git push to publish my local commits to the remote, because at this point we're out of sync. If somebody else cloned the remote repository and then made a bunch of changes and then pushed, then I would now be totally out of sync with that new person who cloned and also the remote server, and it would create something called a merge conflict, which is like a little bit more advanced in this video, and we'd have to take steps to resolve it. So the smartest thing to do is, well, if you're coordinating with a team, make sure that everybody is designated a certain file or set of files to work on, and you all talk to each other. Hey, I just pushed some code. You need to pull. Hey, I'm about to push. Hold off a second. Hey, I just pushed. If you're working on something, you got to pull my changes before you do a push. Always push after you commit, so that everybody has the latest copy on the remote, so you don't cause conflicts with your teammates or whatever. And always try to do pulls regularly. Anyway, so I need to push my code. I'm going to say git push, and it's saying, oh gosh, what is it saying? Oh, okay. This is going to be a special setup that I have to do. Let me just very quickly revert what I'm doing here. I think I have to, oh, I know what to do. I can just make it a little trick. Usually the thing is they don't want you to push onto a branch that the remote has currently checked out into the file tree. But usually remote servers, they don't have a branch checked out. So you won't even see the file system on the remote. It'll actually all look like just this. There's a flag called bear that you can use to make that happen, but I don't really want to go through all the steps right now. So what I'm going to do is I'm just going to make another dummy branch and then just kind of sit on it for a while. That way I'm allowed to push to the master branch. So I'm going to say git branch. This is how you make a new branch. I'm going to say dummy or something. Whoops, got to spell branch right. Then git checkout dummy, and then git branch all, and then git status, just to make sure I'm now sitting on the dummy branch. And then this will cure the problem that we had a moment ago where we're not allowed to push to a branch that the remote has checked out. So I'm going to say git, oh wait, hang on, got to go back in there. My clone, git push. Okay, so now it works. So keep in mind, if you're pushing to a remote that has a branch that's checked out, like it's another file system, like it's a friend's computer, you're going to have to worry about this sort of thing. But if it's a server like GitHub or just someone who has set the repository up properly, you won't have to worry about it. So forget about that for now. So I pushed to the remote. If I do git log over here, there's a mix. It shows, Mike created it and then changed it, and then the clone dude added something too. Okay, so if I say git log, we should now see the history for only the dummy branch. So that's just 2 things. And if I say git checkout master, and then I check out, and then I look at the log for the master, I can see all the changes that the other person made. Pretty cool. I could also go back into the dummy branch if I wanted to. I actually used to do this a long time ago before I realized you should do bare repos. Let's see, check out dummy. And then I'll say git log just to confirm that the changes aren't in there. So now we have two branches that are kind of diverging a little bit. The master branch has one more commit than the dummy branch. And if we let this go on for far too long, it might be more of a hassle to make the branches merge again. But I'm just going to merge them right now. So I'm going to say git merge. Verify that you're sitting on the correct branch that you want to be the destination branch. So I'm sitting on the destination, the dummy branch. So I'm going to say git merge. And I'm going to give it the name of the branch that I want to merge changes from. So git merge master. It's telling me that something happened. So if I do git branch again one more time, I'm still on the dummy branch. But if I do git log, notice how I have that latest log entry. Pretty cool. So now I'm going to go back onto the master branch because I want to do some work here. This is a little clumsy. If we're talking about a server client paradigm, just bear with me. Now I'm going to make another change. Hi, Mr. Clone. Can you read this? So I'm going to make a change that I want the clone person to see. Git status, git add, the readme. You could also do git commit -a, but I kind of don't like to because I like to remind myself that the stage is a good idea. Git commit new readme for cloney. Oops. Git status. Okay, so I don't have a remote. I am the master, so there's nowhere to push. But now, in the clone, I can say git status. It doesn't yet know that the remote has changes. I could do git pull to actually pull all the changes, or I can do git fetch. Fetch will sort of talk to the remote and pull the changes into this repository's local copy of the remote. So if we do git branch all, you'll notice that we have a master branch here. So the master branch is my master branch, and all these other branches here are local copies of the remotes branch. So we're just making lots and lots of copies. That's kind of how Git works. But now that we did a fetch, that talked to the remote, it grabbed changes. If we do git status, now Git understands that we're actually behind the remote by one commit. And it's telling us, well, you need to use git pull to pull all the changes. Usually, you kind of don't need to do git fetch. If you have a remote, you just say git pull. You only do git fetch if you want to kind of see what's going on with the remote first before you actually try to pull all the changes into your branch. It's a more complicated situation. But so if I say git pull, now inside of my git log, I have that last change that the master gave us. So this is like a very, very basic workflow for Git in terms of, making changes to your program, committing the changes, checking out the log, checking out what was changed, pushing to a remote, and so forth. The only difference, by the way, between using a remote that's a file system and using a remote that's GitHub is just what URL you put in clone. Like if I said git clone, I put a file path here originally, but if I just put a clone URL that GitHub gave me or your friend's server gave you right there, then it would work basically the same way. It's pretty sweet. Let's see. So those are the basics of Git. Always make sure that you push to the remote so that the server has your changes. And if you're using GitHub or another website, it's usually a really good idea to push and then go to the website to double check that your changes actually made it. So we talked about tags and branches. This video is not going to be for advanced branching strategies, but there are lots of cool resources you can check out. Actually, you know what? I'm going to pull one up. Let's see. I'm going to edit this out if it ends up being like a really bad search result. Git branching strategy. So if you're working on a big project with a big team, let's see. There's one that I used to love. Where the heck is it? I think this, no, that's not the link I remember. I should have bookmarked it. But there are lots of different strategies for how and why you would want to use branches. Let's see, one of these has a good diagram. This is it. This is not the same web page, but I think this website stole the diagram that I remember. So we've been on the master branch. That's like the right side here, this little these little blue dots. Imagine that every single time you want to create a new feature, you just create a branch and you name it after the feature that you're creating. I think I mentioned that before. That allows you to sort of keep working on the master branch independently of the feature that you're working on. And then later, when you're sure you want to merge the feature into the master branch, then you just use a git command to make the two branches merge. Or if the feature turns out to be a bad idea, you can just delete the branch. Usually at minimum, most people will do something like this. They'll have a development branch. So here you can see the yellow dots, that's development. And what they'll do is they'll make all of their commits to the development branch. And then only whenever the program is in a really good state, like it's sort of presentable, you can actually release it. You can let the public download it, or you can let your friend run the code or whatever. Then you'll merge the dev branch into the master branch without deleting the dev branch. So you'll merge the dev into master every time the code is in a really good state, and then you'll come back onto dev to continue developing. I think most people call it develop, actually. I call it dev for mine. And that way the master branch usually only ever is in a state that is good, that people could clone from and just compile the program or use the program or whatever. And that is in addition to adding tags whenever you think the master branch is in a state that you think is like a significant release. So like version 1.0 or 1.2 or whatever. So branches for development, where you're always there most of the time. Branches for feature, when you're kind of experimenting and trying to figure out if you're going to be able to add something. There's a branch for the master, where it's like, this is the state that the public should see, the state that actually works. And then, you might do a temporary branch for a hotfix. And sometimes people will do a new branch for a future release. Like if you're going to release version 2.0, you might make a new branch and call it version 2.0, and then just work on that and kind of like merge changes from dev in that, and just make sure that it's all good and it's great. And as soon as you think that the feature branch is perfect for your release, sorry, not feature branch, release branch is great for your release, then all at once you'll merge that whole thing into master. You don't have to do it that way. It doesn't have to be that complicated, but sometimes it can be that complicated. For me personally, I usually just do a development branch and a master branch. And then sometimes when I'm taking a risk, I'll make a branch for, I'll make a feature branch for like the new thing that I'm trying. So I just kind of wanted to show you that for branching. And we talked about pulling and pushing and cloning. Yeah, so just I guess one more warning to make sure that you don't end up with merge conflicts when you're collaborating with other people, or even actually this happens to people who work by themselves and they just switch computers a lot. Make sure that when you first sit down and you're about to start coding, you always pull. And if you're working with a team of people, communicate with them and tell them you're about to pull, tell them you're about to start working on something, tell them what you're about to start working on, unless you have like a manager who's telling you exactly what to work on, then it's their problem. And then do your git pull, and then work, and then every time you make significant progress, do a commit, and then tell everybody I'm about to push, and then make sure that you just keep doing that. So if you go on your lunch break, make sure you push before you go on your lunch break. And when you come back from your lunch break, make sure you pull right away, because if you don't pull and push enough, you're either going to get merge conflicts on your end, or you're going to cause other people to get merge conflicts. And sometimes it takes a lot of time to resolve the merge conflicts. So you really don't want to deal with that. And then a beginner's tip, or I guess maybe an easy tip. I do this actually sometimes. If you end up totally forgetting to push and pull, and you do a lot of code and you kind of wreck everything, and you don't want to deal with a gigantic merge conflict resolution type of situation, sometimes it's easier to just copy paste your folder somewhere else, rename it. Remember, a Git repository locally, it's just a folder, so you can copy paste it or rename it or whatever you want to do. You just kind of copy paste it somewhere and then perform a fresh clone from the remote. Then there's not going to be a merge conflict, because the fresh clone is going to be directly from the remote, which is not conflicted on its own. Then you'll have your fresh clone, and then you'll have your little backup copy of what you just screwed up. Then you can manually inspect the difference between the fresh clone and then the thing that you just screwed up. Or you can just start copy pasting some of your changes and then do a commit and then do push, and then it should be okay after that. All right, so that concludes our Git Basics tutorial. I hope you learned a little bit of stuff and had a little bit of fun. I will see you in the next video. Hey everybody, thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.